Welcome back, guys. Okay, in previous lecture we just stopped after the third property. Now we will see the fourth property, that is inverse Laplace transform of integrals. This is a very easy property. That is, if the given function is in the form L inverse s to infinity f of u du, our answer will be f of t by t. That is the inverse transform of integral, or if the function of s is given in the form s to infinity f of u du, it will be f of t by t, and this is the our f of u, so it is actually f of s, and from this we will get f of t by using inverse transform, and if we divide the answer, it will be our uh, actual answer. Okay, so this is an example of the inverse transform of derivative. You may understand what is the properties. Okay, s to infinity, it was in previous, that is from Laplace transform, it was the property of division by t, that is f of t by t. Okay, so we can write f of s equals, just replacing u by s, we can write this whole term, that is our function of s. Okay, you can also write by using u, no problem, but if you write s, it will be easier to understand. Okay, so these are in a very simpler form, so apply inverse transform and you will get accordingly this is this f of t. Okay, and your answer will be in this form. This is a very easy. Okay, now we will see property 5, division by s. Okay, this is one kind of important property. Okay, if L inverse f of s equals f of t, then L inverse f of s by s, it will be 0 to t f of u du. Okay, that is, if the given in function of s is divided by s, its inverse transform will be 0 to t capital F of u du. Okay, so we need to find f of u, that is our actually f of t. Okay, we will get this from f of s. Okay, so let us discuss with an example. That is the problem, L inverse 1 by s square into s plus 1. How we will identify whether the given integral is division by s, inverse transform is division by s property. Okay, if you find any free s, whether it is s square, s cube, or s power, any integral power. Okay, if you find any free s with any other functions, free s in the denominator, then you are sure that the given inverse transform is in the property matches with the property division by s. Okay, here I have written s, but it can be s square, s cube, or any power of s. Okay, so and for each s you will have to integrate the whole function according to the power of s. Okay, so you will understand if you see the example. Okay, now see, so we are sure that the inverse transform is in the form of division by s, so we will have to take f of s except this term. Okay, the term containing s, okay, or free s, so except this term, the other function will be our f of s. So here f of s is 1 by s plus 1, and accordingly its transform function is e to the power minus t. Okay, that is our f of t, and according to the property we will have to write, since there was s square, now first we will work for a single s, that is f of s by s, it will be 0 to t e to the power minus u du. We will have to replace this t by any other variable. You can write u, x, v, y, whatever you like except t and s. Okay, so if we integrate, you will get this minus e to the power minus t plus e to the power 0 according to the rule of integration, definite integral, and accordingly you will get 1 minus e to the power minus t. Okay, and now since there was s square, you will have to integrate this again. Okay, so again we can write L inverse f of s by s square, it will be 0 to t 1 minus e to the power minus u, just I have written u instead of t, du. Now integrating this, we get u plus e to the power minus u, limit of integration is 0 to t. So accordingly you will get this. Okay, and this will be the answer. If there is s cube, then you will have to integrate this by replacing t by u in this form and again integrate. Okay, so this continues until the power of according to the power of s. Okay, now we will see our most important property, that is the convolution theorem. Okay, so what is convolution theorem or convolution property? That is our convolution theorem and convolution property. Actually this is a property something like if more than one function, I mean two function are given in the form something like f of s or g of s, that is called the product form. Something like we can write L inverse 1 by s minus 1 into, say, for 1 by s square plus a square. Okay, these are different functions but they are in product form in the inverse Laplace. Okay, then how we will evaluate this type of transform? Okay, so this type of transforms are evaluated by using the convolution property. Okay, so if we make the given integral in the form like f of one function is f of s, another function is g of s, then this transform will be found by the convolution theorem. Like if L inverse f of s equals f of t and g of s is g of t, then in multiplication of these two functions inverse transform, it will be 0 to t f of u g of t minus u du. Okay, that is we sometimes denote by f, writing f star g. Okay, so if we write f star g in inverse transform, this will mean the conversion of f and g. Okay, now we see we will prove something like f star g equals g star f, that means the conversion of f and g and the conversion of g and f will be same. It has another meaning. We will have to choose f and g, like f and g, like I have written, I can choose this is f of s and this is g of s, or I can choose this is g of s, this is f of s. No problem. This property means we have no problem which function we choose g and which function we choose f. Okay, and also in the property 0 to t f of u g of t minus u du, if you write 0 to t g of u f of t minus u, there is no problem. Okay, both will give the same result. Okay, so this is the significance of this proof. So we will mathematically see this. Right, we have f star g equals, this is the conversion formula. We will just change this variable by another variable, like you writing t minus u equals to v, and its derivative becomes dv, and this is dt minus du equals to dv, and since t is the limit of integration, so it will be constant here, and accordingly dt will be 0, so it remains minus du equals to dv, that is du becomes minus dv. Also we will have to change according to the property of definite integral. If the lower limit of u is 0, that is lower limit of u is 0, if we put 0 here, it will give v equals t, so it is t. And if if we put use upper limit t, right, t here, t minus t, it will be 0, so it will be, so v will be 0. Okay, So just we now we will just substitute. Okay, therefore 1 implies, so lower limit for 0 it becomes t, and t becomes 0, so t to 0, and u becomes, here we can write t minus u equals to v, so minus u equals what, v minus t, and u equals to t minus v. Okay, so we have written f of t minus v, and it will be t minus u equals to v, so g of v and minus dv, and accordingly this minus comes first. We have written g of v first, and we have abolished this minus by exchanging the upper limit and lower limit. Okay, we know it, if upper limit and lower limit are exchanged, a minus come, and this minus becomes plus. Okay, so from this we can write g star f, that is f star g equals g star f. So there is no problem whether we choose f of g, f and g left or right. Okay, so we can choose any function f or any function g. Okay, so now we will use this property to evaluate inverse transform like this. Okay, so we are told evaluate the following by using convolution theorem. Okay, so number 1, L inverse s by s square plus s square whole square, s square plus s square by s square plus s square whole square, or L inverse 1 by s plus 1 into s plus 4. Okay, so what is the procedure of using the convolution theorem? Okay, we will discuss step by step. So at first we will have to write the given function in the product form in a convenient way. Convenient way means if we apply inverse, then we will so that we can easily get its inverse transform. Okay, so we have written s by s square plus s square whole square in the form s by s square plus s square into 1 by s square plus s square. Okay, since we know its inverse transform we know, and its inverse transform we also know. Okay, so we have taken the first function in the is as f of s, and the second function is g of s, and accordingly applying inverse we will have to find f of t and g of t from both functions. Okay, now you will have to apply convolution theorem, writing by definition or by the convolution theorem. F star g, it will be 0 to t f of u g of t minus u du. Okay, no matter if you write something like 0 to t g of u f of t minus u du. Okay, no matter you can write. Okay, but we will use, by if we use this, our function will be in this form. Since f of t is cos at, it will be cos au, and there is 1 by a sin a, and this t will be replaced by t minus u, so this is t minus u. Okay, so if we use this formula, we will have to write 0 to t 1 by a sin a of au and cos a into t minus u du. No problem. Okay, you can solve by writing this in this way. Okay, so after that, this 1 by is constant, so we have keep this out of the limit sign, and this is cos au, and we have expand this by using trigonometric formula property, sin a of t minus u, that is sin a minus b, so it will be sin a cos b minus cos a sin b. Okay, so since the limit of integration is t, contains t, so each term containing t is constant here. So this sin at and cos at both are constant, so we can keep them this way. Okay, the third line, you see sin at and cos au becomes cos square au, also cos AU, and sin AU it becomes sin AU cos AU in the multiplication form. This is cos AT, and we in the next line we can keep sin AT out of the integration symbol, and also cos AT. Okay, so it will be cos square AU, but we cannot integrate with cos square, keeping square. So we have taken 2 here and balanced by dividing by 2. So this become 2 cos square u, and here also 2 sin AU cos AU. Okay, and we know that 2 cos square AU means 1 plus cos 2 AU, and 2 sin AU cos AU means sin 2 AU. Okay, or I mean sin 2A. Okay, and then we can easily integrate, and it will give this u plus cos becomes sin 2u by 2a, and this becomes minus cos 2u by 2a. Okay, and then after putting the limit t sin 2at by 2a, and for 0 this becomes 0, this also becomes 0, and from here cos at by 2a to a 4a square minus minus plus cos 2at minus cos 0. Okay, and for the next line we get multiply by multiplying 1 by 2at sin at plus 2a to a 4a square sin 2at sin at plus 1 by 4a square cos 2a cos at minus cos 0 means 1, so multiplication gives cos at by 4a square. Okay, and from the in the next line we know cos a cos b plus sin a sin b. This 1 by 4 square is common, that is cos a cos b plus sin a sin b. It becomes cos of a minus b, so this becomes 2 at minus at. Okay, so 2at minus at, what it gives? Cos cos 2at minus at, it gives cos at 1 by 4 a square. So there is also 1 by 4 a square. This is plus 1 by 4 a square cos at, and this is minus 1 by 4 a square cos at. So this cancels each other, and our answer is this. Okay, so thank you, and practice the other 2 problems by using this technique or procedure. Okay, so up to this we will come with next lecture with some other workout problems. Okay, up to, take care, thank you.